Okay guys, so this is going to be our first attempt at maybe a video for a section we haven't talked about a little bit in class. So this is section 8.3, and we're going to talk about absolute value functions for just a minute. Oops, let's spell value right. Okay, so I'm hoping that we remember at least just the definition of what an absolute value does. So we talked about this a little bit earlier, but let's just pretend we haven't. So here's some symbols, and really what I mean by this symbol is I mean the function that takes kind of absolute value. So in words, right, the definition of this symbol is that the absolute value of x is the distance that x is from 0. So that looks like this. Here's a number line. Here's 0 on this. Maybe here's our x that we're interested in. The absolute value is this distance. Okay? That works similarly if we have a case like this. So here's a number line, and maybe in this case x is a negative number, right? One that's less than 0. Then the absolute value of x is still defined to be this distance. But we measure that in the same way we measure distance. So if this is, say, 3, then this absolute value would be 3. If this is negative 3, then this distance is still 3, so we would get a positive value out of it. So that's what we mean in words, right? In terms of a more concrete expression, which most of you would probably like, f of x is absolute value of x is the same thing as something that we've never seen before. This is called a piecewise function. So we're going to define this on 2 pieces. So it returns the x, right? It gives you back the same number if x is bigger than or equal to 0. And it gives you back the opposite of x if x is less than or equal to 0. Maybe less than 0 just. So what does this mean? This means that if we want to do something like f of negative 3, that this is the absolute value of negative 3. And this would be, how far is negative 3 from 0? Well, it's 3 from 0. Cool with this? So this is our definitions for absolute value functions. All right, now we should do some more examples. We also need to draw this thing. I'm working on kind of a small board here in hopes that you can read all of this business. Okay, so let's graph. So, graph f of x is absolute value x. Okay, so we need to think about what this thing does. So here's our x's, here's our y's, right, our outputs. So if I put a value in over here, right, it returns this distance. So I go up that same distance for an output. So I put a dot there. If I go over this distance, I'll go up that same distance as an output. So I'll put a dot here. I know that 0 is 0 from 0. There were a lot of zeros in that sentence, right? But that just means that the point 0 is both an input and an output on this thing. So if I want to connect the dots, I connect the dots this way. And I notice that this is the same thing as the line y equals x. Right? And that's true for the positive half. On the negative side, if I go over some amount, right? This is, say, -1 or something. Then I have to go up that far. So I go up that far, right? That's what the return is how far it is from 0. So I get another set of dots. So like this one has distance this far from 0. So I get that distance this far from 0 as an output. So I get another one of these, oops, that one's off. So I get another one of these lines, and this one is the equation of, or this one is the same as the line with the equation y is minus x, at least on the negative stuff. So what I'm thinking over here is I'm kind of thinking, well, this is like y equals x. And over here I'm thinking, well, this is like y is minus x, which is why we wrote down that other formula. So we might remember that the absolute value of x is the same as x sometimes, specifically when x is bigger than or equal to 0, and it's the same as minus x sometimes when x is less than 0. Okay, so here's graphing absolute value of f. Now if we want to graph absolute value of, say, something else, so we want to do another example where we graph say g of x, and g of x is the absolute value of x plus 1. Well, what does this look like? Well, can I get some points on it? Say what's g of 0? So when I do g of 0, I plug 0 in for the x up there, right? So I get the absolute value of 0 plus 1. And now when I calculate this, I get 0 plus 1 is 1, right? So the absolute value of 1. How far is 1 from 0? Well, it's 1, right? Okay, so I know that if I put 0 in, right, 0 on my inputs gives me 1 on my output. So I get a dot here. Now if I want to do, say, g of negative 1, I get the absolute value of negative 1 plus 1. Negative 1 plus 1 is 0, so this is the absolute value of 0. Now, how far is 0 from 0? Well, it's 0 from 0. So when I put in minus 1, I get 0 out. So minus 1 is an input, right? Back 1 gives me 0 output. If I want to calculate something like, say, g of 2, I get that this is the absolute value of 2 plus 1, which is the absolute value of 3. So I get 3 out of this. So that tells me if I go over 2 units, I should go up 1, 2, 3 units. If you kind of continue in this vein, you'll find, oh, we should probably do one of the ones on the other side too. So let's do, say, g of negative 2. So g of negative 2 is the absolute value of negative 2 plus 1, which is the absolute value of negative 1. So how far is negative 1 from 0? Well, it's 1 unit, right? The absolute value function in some sense just loses the minus sign, right? So we get 1 out of that. So I need to go to x is negative 2, that's here, and then I should go up 1 unit. If we continued in this, we would find that there's a V shape which has moved from where it was for absolute value left 1. And this is what's called a shifting rule, which we'll get into later. But for right now, I want you to take this technique. So plug in a few points, find the V shape for now. That's only going to work when you're either adding inside, adding outside, or when you're putting a minus sign on here. If you put a minus sign on there, what happens? We put a minus sign on there, so if we want to graph instead, say h, so this is another example, right? We want to graph h of x, which is minus absolute value of x. We could do this by finding some points, right? So we say, okay, what's h of 0? That's the absolute value of, oops, that's minus the absolute value of 0, which is minus 0, which is 0 still. If we do h of 1, we get minus the absolute value of 1, which is minus, the absolute value of 1 is 1, right? Okay, so graphing these. See, I got 0 as an output when I put 0 as an input. When I put 1 as an input, I got minus 1 as an output. If I keep doing these, like say we do h of minus 2, that's minus the absolute value of minus 2, which is minus, oops. How far is minus 2 from 0? It's 2. So I get minus 2. Oh, so that put out the same thing that I input, right? So I go over 2 to my minus 2, and then I go down 2 to the output negative 2. So if I keep doing this, I'll find a V shape. And that V shape is what? Flipped over from the other one. So when we multiply by a negative 1, it flips over this way. And that's what happens when we multiply on the outside. There's another rule for multiplication on the inside that we'll cover when we get to shifting the rules. You guys could actually try, and it would be a good idea, on your own, to try to graph. Oh, I don't know what we should call this thing. Let's call this capital G of x, maybe, which is absolute value of minus x. See if you can graph this on your own. It'd be good practice. All right. Bye, guys.